Hello, welcome back to chapter 13.1, right angle trigonometry. In an earlier video, when I showed you this paper, this is from example 1, we first introduced the idea of the trigonometric ratios, SOHCAHTOA. Sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. There are 3 sides of every triangle. For a right triangle, there are 2 legs and a hypotenuse. And we keep the legs different, separate I should say, relative to which angle you're talking about. So if this is my angle in this corner, then this side's opposite, this side's adjacent. If my angle is up here, now this is opposite to that angle. This is adjacent to that angle. Okay, so we got that. There are 6 ways to make a ratio if I've got 3 sides. These are the first 3. So in this example, we're going to talk about the other 3. Now, if I show you my calculator here, I've got sine, cosine, tangent on my graphing calculator. And again, if I had a what we would call just a scientific calculator, which I think, I'll grab this one. No, it does not. That's okay. Sorry. I had another one. I thought it was a scientific calculator. But if I look at it like a scientific calculator, doesn't have the graphing component. It looks like this. Okay, but that's not that one doesn't have the trig functions on it. But notice that there's 6 ways I can do it. Well, where are the other 3 at? Well, we don't put them on the calculator because we don't need to. The other 3 are the reciprocals of these. So, and I'll try to keep going back and forth. So sine, I'll use this one. Sine is opposite over hypotenuse. The reciprocal is hypotenuse over opposite. Hypotenuse over opposite we call the cosecant. Cosine is adjacent over hypotenuse. The reciprocal is hypotenuse over adjacent. Hypotenuse over adjacent we call the secant. And these are the words, just like this page, these are the words highlighted, and then the 3-letter combination is the shortcut for it, the abbreviation. For the tangent, opposite over adjacent, the reciprocal becomes adjacent over opposite. That is the cotangent. Now, it's a little confusing as to why cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. Okay, the best way I can explain it is that sine and cosine go together because co stands for not, it doesn't mean like I work with a teacher in one of my intermediate classes. He's my co-teacher, all right, so we go together. That's what we always thought the co meant, but actually what it means is complementary. And I showed that in the previous video where the sine of 30 degrees is equal to the cosine of 60 degrees. Because the complement of 30 is 60. So it's the complementary sign. Okay. So that's why sine and cosine go together, and that's why secant and cosecant go together. As for like which one goes with which, that's a little that just comes down to usage. And also there's another thing that I don't really know if I want to get into with the video, but it's good to explore, is that tangent comes from geometry. A tangent line is a line that basically touches a circle at one point. A secant line actually kind of cuts through a circle, and it goes into the circle and comes out. All right. So like a diameter is a special type of well, it's part of a special type of a secant line. The sine, I've only ever heard sine in one place, and now I need to look that up. So here's the other ones. Cosecant, secant, cotangent. The abbreviations for cosecant are CSC, secant is SEC, and cotangent is COT. And again, Dr. Berger's not putting the parentheses around these like he should be. All right, so we're going to do what we did except now we're going to find all 6. So I'll start by just making a list. Sine of theta, this is going to be opposite over hypotenuse. Cosine of theta, and the only reason I'm doing it in this order is because of this. It's kind of just our way of remembering it, okay? The order, writing sine, cosine, tangent in that order, which again, that's what you're going to see, sine, cosine, tangent. There's no reason for it. There's no reason why we do them in that order. Just, it helps us to remember it. That's the only reason. And this is going to be opposite over adjacent. All right, so let's figure these out with the fractions that we have here. Here's theta. Now, this side that is opposite of the right angle is always going to be the hypotenuse. This side that is part of angle theta is going to be adjacent. And the side opposite of angle theta we call opposite. Now you might notice something. The adjacent side is 14 and the opposite side is 48, but they didn't give me the hypotenuse. How do I figure that out? Well, if I say the hypotenuse squared, I get 14 squared plus 48 squared. I'm going to use the Pythagorean theorem. And I'm also going to use my calculator. So I do 14 squared plus 48 squared. And I get 2,500. And if I take my square root of that, which you actually probably could do in your head, I get 50. So using the Pythagorean theorem, I found out that my hypotenuse is 50. And I also notice, and this will happen when I start to write this down, I also notice that this is 2 times 7, 2 times 12, and 2 times 24, and this is 2 times 25. So this is another Pythagorean triplet, and it's a scaled up version of 7, 24, 25, which is another famous Pythagorean triplet. We did everything to where we weren't going to get any like irrational numbers. So sine is opposite over hypotenuse. That's 48 over 50. And that's going to reduce to 24 over 25. Cosine is adjacent over hypotenuse. That's going to start out 14 over 50, and that's going to reduce to 7 over 25. And tangent is opposite over adjacent. Opposite is 48, adjacent is 14, so I say 48 over 14, and I reduce and I get 24 over 7. And you can leave 24 over 7. Like I said earlier, I don't need it to be switched to a mixed number. Okay, now, sine of theta is opposite over hypotenuse. This goes with cosecant of theta, which is the reciprocal of that. Now, so I can say hypotenuse over opposite, 50 over 48, which is the reciprocal of this. I already know that the reduced form is 24 over 25, so I can go ahead and find the reciprocal of this. This is just going to be 25 over 24. Secant of theta is the reciprocal of cosine, so that's going to be 25 over 7. And cotangent of theta is the reciprocal of the tangent. My tangent was 24 over 7, so this is going to be 7 over 24. And if I'd gone back and said adjacent over opposite, 14 over 48, and then reduced it, that would have been perfectly fine also. Again, there's no reason for the order that we put things. We do sine, cosine, tangent just because it helps us with the mnemonic, and also because we see it in lots of places. And the reason why I wrote cosecant, secant, cotangent is because that way these are paired up just like that. Let's do another one, and then we'll start doing the problems in the back of the book. Or not the back of the book, but the problems in the back of the section. Okay, so again, I've got angle theta, This is the side opposite of theta. This is the side adjacent to theta. And this is the hypotenuse. I need to figure out what the hypotenuse is. So I'm going to figure out, I'll write it this way. Hypotenuse squared is equal to 18 squared plus 80 squared. So I got 18 to the second power plus 80 to the second power. I get 6,724. Take the square root of 6,724, and I get 82. So the hypotenuse is 82. And I already know that these are all even numbers, so at least they have a common factor of 2, which means that I'm probably going to reduce or simplify. So sine of theta, again, is opposite over hypotenuse. This is going to be 80 over 82. And looks like the only common factor is going to be 2. So if I simplify, I get 40 over 41. Cosine of theta, cosine is going to be adjacent over hypotenuse, so I get 18 over 82. And if I simplify, my common factor is 2, I get 9 over 41. And finally, tangent of theta is going to be opposite over adjacent, 80 over 18. And reducing that is going to give me 40 over 9. To find the other 3, the reciprocal of sine is cosecant. So cosecant of theta is the reciprocal of this, 41 over 40. I'll go ahead and use the reduced form. The reciprocal of cosine is secant. Secant of theta, the reciprocal of 9 over 41, is 41 over 9. And again, just like this one and just like this one, you can leave it as what they call an improper fraction. The reciprocal of tangent is cotangent. The reciprocal of 40 over 9 is 9 over 40. And there are the values of the 6 trig functions for that angle theta. We'll see you in the next video.